Good afternoon, geometry guys. It's Mr. Jeffries coming at you. Don't forget to hit like and subscribe with the bell. So, we are going to be looking at the area of trapezoids, kites, and rhombuses today. Alright, so here is our formula. Okay, H is our height. Now, our height is always going to be beside this right angle because it's perpendicular. Okay. And then our B sub 1 and B sub 2, or B1, B2, it doesn't matter which one you choose because it's adding. Order doesn't matter when you're adding. Alright, so times 10 plus 50. Now, you don't have to actually write it like that, you know, type it in the calculator. Alright, so 10 plus 15 is 25, which is not as funny as 24. So we get 162.5 miles squared. Okay? Now, in the nutshell, that's basically what we're doing right here. I mean, that's the Cliff's Notes or Star Notes, whatever y'all have now. Okay, so where y'all are going to have some issues will be problems like 7 through 9. And this is why. We're missing measurements. Okay, we're missing measurements. But we have some other things going on. We know that this should be 10. All right, this tells us that this is a 45, 45, 90 triangle. These right here with the dotted lines. Well, 45, 45, 90 says that the legs are the same. It's been a hot minute for, you know. So our B2 right here would be 5 plus 10 plus 5, which is 20. Okay, so that's the length that you're missing here. All right, on number 8, all right, that's also 7. This is a 30, 60, 90. Okay, 30, 60, 90 says that this short leg is half of the hypotenuse. Well, what's half of 4? 2. Good. Wow, really worried about it, especially as supposed to be honors class. Okay, now this you don't have to tell me you're back. I'm not freaking blind. Okay, after we just had to have a brief intermission because people needed attention. Okay, so this is half of this. This right here, this would be our long leg is the short leg times root 3. Why are we still talking? Why do we have all these other conversations going on? I don't know either. All right, now this tells us that all these are the same. All right. This is a 30, 60, 90. Here's our hypotenuse. Tells us that this leg right here is half of 20. What is half of 20?
10.
10. That also means that this is 10. Okay? So, with these 1 through 9. Now, let me make this really clear because we had people in 4th period that didn't do these problems because they said they didn't know they were supposed to be doing them at this time. So, let me make this great announcement. You are supposed to be doing 1 through 9 on the front side of your handout right now. Okay? Because I'm going to pause the recording, and you're supposed to be working on 1 through 9 on the front. Okay, and we'll be coming back. All right, kind of jumping back in, we're going to look at number 8 right quick because we have to do some things that's not really covered so far in geometry. So 7 plus 9. All right, so 1/2 2 root 3, 16. So you treat the root 3 kind of like its own variable, kind of like x. So what you would do is you would basically type in 0.5 times 2 times 16. All right, we get 16, and then we just tag along the root 3 right here. Okay, so this would be 16 root 3 for that answer. What? What does the direction say? Leave your answer in simplest radical form. Okay. So in thinking about some of this stuff, other than, I may give you a problem that looks like 7 through 9 that I would ask you, what are you missing? What measurements are you missing? And how would you find them? I'd rather know that other than you give me an answer like on 7, 8, 9. I know that sounds weird, but we did an experiment with a couple of classes last week on their test since they wanted to, be more annoying than a hemorrhoid on a bumpy road. And I changed the format of their test. They all said it was hard. Most of them actually scored quite well, but they realized that they knew the material, even though it might not be in the same format. Which means the way I'm teaching you, if you have a standardized test, you should still kind of know what to do. All right. So, yeah, I know there's a lot going on. Tomorrow we'll have practice problems and a check on learning, but that way you'll kind of get a better sense of where I'm heading for some of this stuff. Okay? All right. Because again, I'd rather you tell me what you were missing and how you would get it other than solving it. Unless it's like a bonus problem. Bonus. Okay, so area of rhombus in a kite. All right. So, this is 1/2 d sub 1 times d sub 2. All right, those are just the diagonals. So like for this one, d sub 1 would be, it doesn't matter which one. It could be the vertical or the horizontal. Okay, so this would be like 9 plus 9, which is 18. D sub 2 equals 12 plus 4, which is 16. And then this is 0.5 times 18 times 16. I hope that's cards and not somebody actually doing an underleg noise because, whew, that'd be bad. I know it's cards. I just think it's funny to say that. What's an underleg noise? Underleg. Yeah, it's from a great cartoon called Ren and Stimpy. Y'all were not around to witness such glorious cartoons. Okay, so this is 7. This would be 7. All right, we could find this length right here by using Pythagorean theorem, like 8 squared minus 7 squared. Okay. See, that's what I'd rather. I'd rather want to know your plan of attack than can you give me an answer. Oh my gosh, can you just All right.
Yeah, we just heard it.
All right. So this is root 15. That's what this measurement is right there. So for d sub 1, 7 plus 7 is 14. All right, that's the easy one. D sub 2 is root 15 plus root 15. That again, this is understood to be 1. See, this is one reason I'd rather, I could ask you to find the missing length or tell me how you're going to get it other than give me the answer. Because this would be 2 root 15. So now we have 1/2 14 times 2 root 15. That becomes, let's say half of 14, 7. All right, 2 times 7, so 14 root 15 centimeters. Now, again, if you're like, where is he getting these numbers? Again, that's not the main thing. I think this will be the 5th time I may have said this, that I'm interested in how you're going to get that missing length other than, or can you find the missing length other than getting the total area? All right. That being said, okay, I don't want to airball or double cross dribble as I'm playing a pickup game in a gym. All right. On 13, I want you to find this length right here. On 4, I just wrote 14. I want you to find this length right here. Okay? I want y'all to label that before I turn you loose to do it. All right. And 15, I want you to find this length. I forget how to do this one. All right. I'm only going to ask you to find this right here. Let me redraw that. That's a bad one. This, because it's there's a lot going on right there. Okay. All right. So that's our lesson as they're working on these problems. Don't forget to hit like, subscribe with the bell. And good stuff, good things. We'll talk.